Hi there! In this video, we will look at more examples on inverse functions. Let's take a look. Given that g is defined by gx, x minus 1 squared plus 3, where x is a real number and x is greater than and equal to 1. Find g inverse. Okay, so to find g inverse, we must always start with the formula g bracket g inverse equal to x. Remember that the next step is to letting this g inverse as y. So we have reduced this problem to be solving gy equal to x. And what does this mean? It simply means that we have to substitute the x from this gx with y. Do not get confused with this arrow sign. This is just gx equal to x minus 1 squared plus 3. That's why to find gy, we just have to replace this x with y. Let's do that now. I will start by copying everything else, this green colored, writing, and then changing my x with my y. After that, on the right side, I still have equal to x. Well, what we want to find is g inverse, and g inverse is equal to y. So that means we have to write y as the subject and leave only y on the left side. So we have to eliminate all of these other terms to the right side. Let's do it one by one. First, start by bringing this plus 3 to the right side, then it'll become x minus 3. After that, we want to eliminate the square. So to eliminate that square, we have to put a square root and plus minus in front of it. So when square root meets square, it will cancel off, and what's left on the left side is just y minus 1. Now, we want only y on the left side. So that means we also need to bring this minus 1 to the right side. And when you bring it to the right, it'll be positive 1. And then behind it is just plus minus square root of x minus 3. But be careful. Look at the function g. It has a special domain. The domain given is x greater than and equal to 1. What does that mean? Always remember that the domain of g function is equal to the range of g inverse. Remember that domain refers to the all possible values of x for function g. And range here means that all possible values of y of function g inverse. And we know that y here refers to g inverse. And we know that range means all possible values of y. So it means that when these two are equal, the domain of g, since it is greater than 1 and until infinity, so the range for g inverse is also from 1 until infinity. So this means the g inverse, or the y in this case, must be 1 and greater. But if I choose 1 minus of anything, means that I will decrease the value of my y, and it will be less than 1, which is not correct for this case. So in this case, we must only choose the positive side of this answer, which is 1 plus square root of x minus 3. So we have to delete the negative part and write the reason why here, since the domain of g is given, which is x greater than equal to 1, which implies the range of g inverse, which is also greater than equal to 1. And that's our G inverse. Now, let's take a look at this next example. The functions f and g are defined by fx equal to zx and gx equal to x squared, where both has domain given as x greater than and equal to 0. A. Show that f is one-to-one function. Remember, whenever we look at this question, one-to-one function means that we have two ways to answer this. One is algebraically and another one is graphically. So let's try by using the algebraic approach first. Do you remember what's the formula? The formula is fx1 equal to fx2. And then what you need to do next is, of course, focus on only the function f. Do not look at function g because right now the question is asking about only f function, right? Then follow the function which is square root of x, but now we have changed our x to be x1. So that means we have to substitute x1 here, and also we must substitute x2. Both have square root. To eliminate square root, we must square both sides. After we have squared both sides, what's left is x1 is equal to x2. Once we manage to show that x1 is equal to x2, then we can conclude that fx is a one-to-one function. Now, let's take a look at the graphical approach. For graphical approach, you must sketch. But don't worry, it's easy to sketch this third function. First step is to check the shape. What is the shape of this function? Look at the symbol in front of that x. As you can see, it's nothing there, which means that the symbol is positive. And then look at the symbol outside of this third. It's nothing there, which means that it's positive as well. If it's negative, then we're going to write negative here. And what I'm writing here is actually the coordinate, or just a method for us to memorize how does the shape looks like easier. After that, this coordinate x positive means that it's on the positive coordinate of x, and then y positive means that we should look at the positive coordinate of y, which means that the graph looks like this. Next step is to look at the starting point. What do I mean by the starting point is here, the point where we start before we draw the graph to infinity. And where should we look at to find the starting point? The function is y equal to third of x. To find the starting point, we just have to take everything that's inside that third, equate it to 0, and you see that the starting point is at x equal to 0. And then substitute this x equal to 0 back into the function of f, and you see that the y is also 0. This means that the starting point is at 0, 0. Next, we can straight away sketch our graph. It starts here at the origin. And here, look at the domain. The domain includes 0. So it means that at this point, it should be a dense circle. And then draw this shape, looking like that. After that, for this graphical approach, remember that you need to do the horizontal line test. Horizontal line test looks like this. Draw a horizontal line, and as you can see, it cuts at only one point on the graph. You can also try to look at the other places on that graph. Does it cut at only one point? Well, yes, it does cut at only one point. So this means that the function f is a one-to-one function. If you're doing the graphical approach, make sure you write your conclusion. Horizontal line cuts the graph at only one point, thus fx is a one-to-one function. Now, question B. Find g(f(x) and define it. To find g(f(x), we have to look at the function given. We know what is the function fx. which is given as square root of x. So we just have to replace that here. And after that, look at the function g. Function g is just x squared. Our x now has been changed to square root of x. So that means we have to write square root of x bracket squared, where the bracket square comes from the function g, and then x has been replaced with our new function, which is surd of x. Square root meets square, then the answer is just equal to x. After we have found g of x, the question wants us to define it. What does it mean by defining it? Well, do you remember this property? You know that f inverse is equal to x. This is the definition of inverse function. But now, we have g of x equal to x, which means that I can also rewrite this as g inverse equal to x if the function is g. But what we get here is g f(x) equal to x. Try to compare. What can you see? I can see that we have the same g in front and we have them equal to value of x. So what does that mean? This implies that g inverse is equal to f. So we can write a conclusion saying that g inverse is actually equal to fx. Or we can also write the function fx here. Without finding the g inverse, we know that the g inverse is actually equal to surd of x. Besides the definition f inverse equal to x, there is also another formula, which is f inverse of f is equal to x. These two definitions refers to inverse functions. Now, if I write it this way, and then I write down what we have gotten here, now I can compare it like this. I have the same f function here, and then I also have them both equal to x. This means that I can compare these two functions. This means that f inverse is equal to g function, where g function is equal to x squared with the domain given x greater than and equal to 0. As you can see, g inverse is equal to f and f inverse is equal to g. So this means g and f are inverses of each other. Now, take a look at question C. We need to sketch the graph of f and g. That's not a problem now since we know this property that g and f are inverses of each other. It is sufficient for us just to sketch one graph, and the one graph that we have sketched before is the function f. So right now we just have to sketch the function f exactly as it is, and then don't forget to draw the line y equal to x, because when we have two functions inverses of each other, the other function will reflect at this line y equal to x. How does it reflect? You just have to try to imagine that there is a mirror on this line y equal to x. Put a mirror here and then reflect this orange line. Here, the graph is closer to y equal to x line, but then it gets further and further from that line. So label your graph. The orange graph that I have drawn comes from the function f graph, which is also equal to the g inverse. And then the green line graph is the inverse of f function, which is the f inverse. So this is also equal to the g function. And we have answered question C, which is sketching the graph of f and g. Okay, thank you for watching.